Good afternoon. I'd like to get started. It's 4 o'clock. Thank you for attending this town hall meeting on the Condo computer. I'm Chris Keene, the VP for Research. I've met many of you, hope to meet all of you soon. Thank you again for coming. I'm just going to give one view graph to start, and then I'm going to turn it over to Christian Mayo and Tony Oppheim as our speakers. So the goal of our meeting today is to outline for you the plans for the Condo computer, quote unquote, which is, as you'll hear from Tony and Christian, has now arrived at the university. And we're preparing to do the acceptance testing. We're working out the governance model. We're very excited about this. We want to get your input on how, on issues associated with governance and how it should be run. So just, very briefly, I want to emphasize this is going to be an important institutional capability for the university for research computing, right? This is similar in spirit to the HPC that was here in 2011, but we've made some important changes in how we run it. We're going to provide more support up front. You hear about that, and also have an up-to-the-date governance model. I want to start out by thanking the range of folks that supported this initial procurement, and it was a large range of people that came together, again, and with the spirit of the institution in view. Connor's provided a great deal of support. I provided some. The colleges have provided support for the support staff that you'll hear about. So it really has been a team effort to get. Of course, IT has been a huge player in this. So it's really been a team effort. I think it goes without saying that this is sort of, as you'll hear about it, this is sort of a 20 teraflop scale machine. It'll obviously bring us a very nice capability intermediate between your desktop and true petaflop supercomputing. But you can do a lot with it in a lot of different areas of research. Christian will talk about that. And what we really like today is your feedback today, and we'll be talking about this further also. Anyway, but I think the point is we're going to have to work together as a team to make this an institutional success. On our side, we've got to make sure the operational and user support is there. And as you'll hear from Christian, we've paid a lot of attention to make sure that the code support person, which is key to success at these machines and other places, is going to be available on day one. And of course, with the faculty, we want your participation in this. That's key to making it work, and we'll talk about the details of how that's done. And we'd like your feedback, again, as part of this meeting. So without further ado, I'm going to turn it over to Christian.
Can you mute your MSI? Can you please mute? Is that okay? Okay, I think that's good. Click it. That's good. Great. Excellent. Thank you. Very well. Well, thank you, Chris. That was a great introduction, and thank you all for participating in this town hall meeting this afternoon and starting a dialogue, engaging a dialogue on research institutional computing at Washington State University. So I want to underscore, two core themes of this little presentation today that are captured in the title of the presentation is institutional computing and community-based model. Because what we want to put forward as the way forward, essentially how the university can come together as a community to advance institutional research computing. So this is very important. And it's also about providing options and creating new opportunities and really coming together as an institution, as the way forward. And Chris said some very, very good words on that topic. And I want to, right off the bat, I want to say, there's lots of people, here around campus, around the site, that work really hard. And I would like to take some time to acknowledge them. First and foremost is the, Tony Oppheim's IT team here has done a remarkable work in really engaging with the research community and really building up to the level that we're at today. And, so don't leave the room if you're in the team, because I'm going to be naming you by name later on, so that you've been warned. And there was also a lot of senior level support from the university leadership, the Office of Provost, the Office of Research, Administration and Finance, ITS. The deans of the colleges also work very hard, again, together to build this thing at the level we're at today. And in particular, I want to underscore the generous contribution of Connors, the College of Agriculture, and one individual in particular, Mike Kahn, who has been truly singular in his institutional perspective, making this happen. So we all, I think that collectively we should really thank these people. So I'm going to sort of give you kind of an overview about the broad outlines of the strategic plan and the implementation plan for institutional research computing. How we got there, where we're at today, what's the path forward, starting with an assessment of the cyber infrastructure needs of the research community here at WSU. So out of this assessment, there were some findings. I mean, we found some things, and then we collected those, we compiled those, and then we suggested some recommendation in order to address these findings. And then I'll be talking about how WSU is moving forward in order to address these findings and to implement these recommendations. And finally, I'll give again the broad outline of a management governance model as we move forward this next phase for institutional research computing here at the university that would sort of have maybe an approach which is definitely more community-based, but also sustainable, that can be refreshed and with somewhat more transparent, somewhat more sustainable, better business model. So we don't have to, we can fight Moore's law in a little bit, so we don't have to, spend $2 million every 3 years in a platform. And then, so these are going to be the broad outline of sort of my presentation. Then Tony outline will put some flesh out exactly what we're doing specifically in terms of hardware and cyber infrastructure enhancement here on campus, including the deployment of a high-speed research network, a research core, which was a NSF grant that we'll be talking about, and also this pilot, the startup, a community-based computer, which we call a condominium computer. It's not a great name, but it's actually, that's the way people called it. And actually, it touches to reality in the way it is actually managed. And then this meeting is about seeking your input. So we want to, this is a dialogue. We want your input, and we want your comments on the management and the path forward. So essentially, we really want to do three things today. We want to, bring you up to speed about what the university is doing in terms of enhancement of its capability, capacity in cyber infrastructure. We want to propose or, describe to you that community-based condominium model for institutional research computing, and then work with you and seek your input. So these are our three objectives. So again, thank you very much for your participation. So there was the plan for the advanced research computing. So how did we start? How do we go about where we at? So last September, there was a tasking memo requesting that the strategic plan for advanced research computing be put forward that would take in consideration the needs and the requirement of the university community, and that this plan be consistent with the then ongoing 120-day study of the WSU research enterprise. So that was the tasking memos. That was the charge. That was last September as the university was looking at its research enterprise. Research computing, advanced, scientific computing was seen a big part of it, and we asked to chart the way forward. So in response to this request, we, in the November, December timeframe, we performed an assessment of the needs of the cyber infrastructure needs of the community, both here on campus with several colleges, but also on the urban campuses. So it was here at Pullman and Tri-City, in Spokane, Vancouver, and we had this video site, and essentially started the dialogue with the community, the different units, and the community at the different campuses to see what their needs were. And again, here I really want to thank the support and Tony's Alpine IT team. It was wonderful working with them. Diane Dickinson, Tory Byington, Wallace Chase, Rob Lyon, Nick Papman, they're all sitting here, really kind of came together, and you can see that this energy and the sense of community building up. And also at the urban campus, well, here on Pullman, I want to thank all the colleges that were very generous with their time, meeting with us, and also in the urban campuses. At Tri-City, there was Joseph Yanelli and Akram Hossain, facilitated your interaction. At Spokane was Salah El Jadi and, Brian Valley. We got together with their team, and then Vancouver, Christine Porfort. So it was really, really good dialogue, and I think that really got things going. So first you got to find out, what's the needs are and where are the gaps and how you fill these gaps. And then, so we found a lot of things. Well, first thing, besides the fact that everybody needs more, data storage. Okay, so we got that part. There were actually some threads. There was actually some common thread. One of them is that, the community would say, well, having better user support would help a lot. Not just system administration support, but also support how do we work with to, more effectively use these resources. Software installation, software development, software optimization. That would be something that would really be useful. That's a term that Mike Kahn, sometimes affectionately calls, meatware. Well, you get the hardware and software, but where's the meatware? Who I talk to get the software installed? So that was one thing. Better upgrade, of the network connectivity was another, thing that came up. I talked about the software, computing software, support for that, which is something that we're gonna we're launching, hiring people to develop a user support group, and also a more transparent governance. We have these resources, and it was somehow the how these resources are accessed, what's the management plan, what is the access policy, a little bit more transparent. So those were the findings. So user support, better infrastructure, and more transparent governance. So the recommendation is, well, we should, stand up a WSU IT governance board, and we've done that. And actually under the leadership of the Provo and Roger Patterson, we created this IT governance board. It was two body, a senior body, the executive board, and then a advisory body, which is the Strategic Advisory Committee, HITSAC, and then there's subcommittee. So now at least we have a forum so we can discuss these issues. So we got that, up and running at the beginning of the year. And then, deploying maybe a more strategic way to deploy cyber infrastructure, which is, better share, sustainable, and also scalable. So there was the infrastructure part of the response to these findings. And finally, something we were very, very attuned to was essentially create this user infrastructure, this user support group that would essentially work with the research community hand in hand in order to optimize and install their software. Because something that we found, there was issue about licensing and common software, and different groups were using the same software, kind of didn't know about that. So now we're having a more institutional view and approach to doing essentially software support. So essentially, that was the kind of the strategy. Well, you have a strategic plan and an implementation plan. So how are you gonna go about implementing your strategy? And it was sort of moving on three fronts that I want to talk about: the cyber infrastructure, the computer platform, and the user support. So last year, the research community came together and formed a partnership with the IT organization to develop a response, to develop a proposal in response to the annual NSF, National Science Foundation, cyber infrastructure call. So there was a partnership that we wanted to forge in order to develop a response to this annual call. And we were, so essentially there were, segments of discipline of the research community here on campus that worked with the IT organization to develop a compelling science case and what would be the enabling cyber infrastructure that could make the science happen and would benefit the university, several disciplines across the university. And we were successful, so we got the grant. we got the cyber infrastructure grant to deploy a high-speed research network on campus, a science DMZ. So we got $500,000 of NSF, which is, and we're buying we're buying equipment, we're deploying it, and Tony's team is doing that. And then but I think there were very two important messages. One of them is that the forging of this partnership between the research community and IT is a very powerful partnership. It's a very powerful alliance. And when the university establishes this partnership and puts forward a compelling science case, we're competitive. And that was a very positive and energizing lesson in test case. So we were very successful doing that. And now, of course, now that we have that, then we can build on that. And now our success of building this partnership can serve as the basis to essentially develop further partnership in the future. And that was the cyber infrastructure. Now the compute platform. So as we move towards refurbishing our current platform, we decided maybe to look at different models. And there were a confluence of events that create a situation whereby there were funds available from the College of Agriculture Connors and the Office of the Vice President of Research that, if put together, could actually create a system, a pilot system that would be modular and flexible and scalable in implementation. And we called this startup system a pilot computer, a pilot condominium computer. So we started with that. As Tony, we have now this thing is being installed, and we got this procurement. But again, that was really a partnership, and it was really the key is really to bring, again, coming back to taking the institutional view, how the different department units can come together so that the greater good of the individual is also the greater good of the institution. And we did that. So we'll be talking to that. But we want to describe this model. And finally, it was this issue of user support. So again, the leadership really stepped up and committed to funds to essentially start hiring a scientific assistant to develop a cadre of people that will interface with the user community and essentially provide user support for software installation, development, optimization on these platforms. So where we're at now is that we have a posting, we have a job posting and description, which is under review by HR, which will be out soon. And in preparation for that, we are essentially reaching out to users and doing an inventory of the software that people use, so we can start prioritizing what kind of software should be installed, what kind of license we need, if it's open software, the license we need to procure, but at least have a community approach. So we're doing that, so when that person comes on board, at least we have kind of a set of priority. And that's something which I believe will be very positive for the community at large. So we're enhancing the cyber infrastructure. We have a new platform, compute platform on site. We have an expansion plan for that. And then we're staffing up both in user support and also I'll be describing in system administration. And again, this partnership between the research community and the IT organization that really made that possible. So we sort of, Chris alluded to that, what's the way forward when we talk about compute platform. So currently the mainframe for high-performance computing here at Pullman is an IBM platform that was procured and installed in 2011, and it has done wonderful work. I mean, just very a lot of great work. Millions of jobs in process, thousands of years of CPU. So that's great. That's really wonderful. But when we look back, we look at say, well, I mean, was it really part of a strategy? What is the strategic outcome? How do we refresh this? I mean, what is the plan so we sustain it? Was there a recapitalization built in? What was the governance model? What was the access model? And then we kind of look at the model and say, well, maybe we can work together as a community to develop a business model, an access model, a scientific model, a strategy, an acquisition strategy, which is more sustainable. And that led us to this concept of community-based condominium computing, which is we didn't invent it. It's used and implemented and deployed at several universities at the institutional level. But it affords an approach which is modular and flexible in architecture. You can set up a transparent governance model, an access policy which is fair and flexible. We plan again to really develop a user support group to work with the user community and to use effectively these resources and to get this dialogue and get feedback. How can we improve productivity, enhance system administrative support, and also importantly, just like since we'll be describing the model, but essentially, since what you own is actually part of a large infrastructure, you have a surge capacity in the sense that unused cycle can be actually harvested and be made available if a user need to do a hero calculation. So it's dynamically, if you want, you have that flexibility or having the capacity to do science at scale, and also to better integrating, software installation, software optimization. And also, again, it provides, more option and create new opportunities. So instead of having, or in addition to having such a standalone cluster, you're part of a larger infrastructure. So at a glance, what is, condominium computing sort of at a glance? Well, as I say, it's a little bit like it says it is. It's like a condominium, just like, your apartment, your condo you bought. It's part of a larger infrastructure, but you own it. Okay, when after work you come, it's yours. So you own, but essentially you also benefit from a large infrastructure. So condominium computing essentially provides users with shares of a larger resource. So how's it done? Well, essentially investors, purchase node or hardware and memory that get installed into a larger framework, a larger infrastructure, a larger system, but they retain ownership. So it's access guaranteed on demand. But then the unused resource of this facility, this shared infrastructure, can be harvested and be made accessible on a priority basis. So essentially, owners and investors have certain, access rights and priority, but the general users that might have either sporadic needs for computing can also have access to the capability. And it's being implemented by having a multi-tier queuing system that is respectful of these priorities. So you can have, if you purchase some hardware, there can be a queue for your jobs, and then you have access to that, but you can also have access to other resources. So it's possible to implement a system in which that priority level and that different access level is respected. And then again, since a part of a large infrastructure, then you realize these economies of scale and integration in terms of software. So who can get in? So it's open to the whole community essentially. Whether you're a sponsor, an investor, an owner, or general user, you will have access to that. But there will be a priority and access rights about priority or how the scheduling goes as the resources are made available. But essentially, it's a shared community resources. Where? So we're starting here in Pullman, so it's in the IT building in room 1010. So this is where, and I'll have a picture of the actual system. And then when? So the system has been, procured. It's being installed right now. The detail is yet to be fleshed out. But essentially, we're looking at, commissioning in the summer and really having steady state and sort of open for business in the fall. So the value propositions are several. It allows the research community access to larger and leverage resource for enhanced productivity. Again, you're part of something big. So again, what's good for you is also good for the community and the institution at large. It affords synergy and coordination in software installation, development, licensing, and optimization. Also, a more transparent model because of these multi-tier, you kind of know what the priorities are, and it allows, again, a more disciplined, a more multi-tier access policy. And also, at the heart of it, this works only, as was repeated, but by really forging, long-term and strong partnership between the research community and the IT organization. This is the only way, this thing works, is really to establish this partnership. And so far, we've sort of demonstrated that this partnership, do work and really can really enhance productivity. So it's really a community approach that at the basis of which are these very strong partnerships. So this thing didn't happen by itself. Okay, it was really made possible by generous contribution and strong commitment from the university leader. So I won't go into all the details right now, but essentially, as I mentioned, there were a confluence of events that led to a situation whereby Connors and the Office of Vice President of Research had resources that they decided they pooled together could be larger than the sum of their parts. And then and again, I really want to thank the college and the Office of Research for really making these resources available, as really creating a critical mass of resource that you could build from. And this is where that pilot scale condominium computing came about. And then we started to discuss about the management, and again, from the findings and the recommendation that we had. And then the university leadership really came together and made resource available, the Office of the VPR, the College of Arts and Science, the College of Engineering, to essentially make available the resource to establish a hiring line for this user support group. Because we say, our point is that, the productivity of this machine will be enhanced manyfold if we have that user support group. And the university came through with that, the leadership came through with that. So that was very successful. And then finally, we sort of, again, made the case that there was need to be enhanced system administrative support. And again, the leadership came with that, the Provo, us Finance Administration, and the, ITS. So here it exemplified that, this way forward really will be made possible, and at the base of this is really establishing a strong partnership between the different organizations, IT, the research community, and the senior leadership, and also the sustained institutional commitment and support, and the input from the users. We really want to continuously improve ourselves as we move forward with this system. So this is where we are at. So at a glance, we procured a system. In steady state and full blown, we're looking at possibly a 9-rack, 60 teraflop machine, where we procure essentially a third of it. So it kind of scales. So at a glance, it's 20 teraflop, peak performance with about 600 terabyte of raw storage. It's being installed in room 1010. It will be, I will be talking about the schedule, but this is the starter acquisition strategy. And the idea is that over time, we will build up from research equipment grants, startup fund, research foundation, institutional support, but also having a system that allows you to expand, makes the university more competitive, because some research grants depend on the university having this infrastructure in place. So now we can actually put forward a case whereby we have an infrastructure that you can build from, and having that nucleation platform that we can grow on actually makes it more advantageous, because you can provide leverage to some of these agencies. So that's also very attractive. So here it is in its live habitat with Nick and Brian, who are sitting here. So we just got a picture. And the reason why I so this is a renormalization slide, okay, renormalization. So this is wonderful, this is great. But before you start talking to your colleagues, say, well, WSU just bought this supercomputer. So, so this is where this fits in the scale of things. So it is a great institutional platform, that will serve as the basis for growth. But what it really does, it sort of bridge, the gap between, research or PI level clusters, which have the, few teraflop, so let's say it complements that. But more importantly, it can prepare the user community to really exploit the capability and capacity at scale of the supercomputer center. So for example, you can by having a platform here which is of institutional level scale, you can do code development, code optimization that prepares you and to be more competitive, to really more efficiently exploit, petascale, ultrascale, exascale supercomputer center, such as these national, facility. So you can, do your development here on site on a good size, 100 maybe scale, 60 to 100 teraflop machine. That also allows you the architecture, which is flexible, to again, capture these opportunities in the supercomputer center. So if I don't know if you would like to port your code on GPU, GPU core, and then so you can request that you have GPU core, which we do, and then you can do development there. So then when the machine at Oak Ridge, the Titan, they say, well, we're going to buy a bunch of GPU core, you're already ready to do that. So it's not a quote unquote supercomputer, but it can prepare the user community to effectively use, supercomputer. Anyway, this picture is not to scale. Okay, so that's just that, And then and finally, just a few words about, the governance model. As they say, at its heart, the condominium model is built on different tiers of ownership and access and priority. And we have to have a governance model that respects that and implements that and manages that. So at different level, you have, at the very high level, you have sponsorship. That could be the college, colleges of some research. Well, the pilot condominium that we have two sponsors. It's Connors and the Office of the VPR. So these are what sponsors are. But then colleges can go and then buy, block of nodes that can be added to the system. So these are the very high level. Then you have single or group level owners, or if you want investors, essentially faculty, group of faculty that have, predictable needs. So they know they do computing for the research. Then they know that they would have to have access to a dedicated facility, a dedicated capability. So then they can buy hardware that then gets installed into this large infrastructure, but then they retain ownership. So they're the owner, the investors. And again, once installed, the purchase node become part of the larger condominium infrastructure, but they retain the ownership. Then you have the general users, and again, those could be users that need, sporadic or just want, try things that may be, low priority. They need to have, less need, and they can have, access, free of charge just to try things, so many cores, and they have access to that. And these are general users. And then you have the institution as a whole, because, this thing sits in a building, it's got cooling, it's got power, so that has to be provided. And the physical infrastructure, the cyber infrastructure, the network, the I/O between the nodes, and also the institution. I just gave the example of how the institution really stepped forward and provide the resource for user support and system administration. So I think it's this, we're still, I'll give a timeline a little later on, but we're still working that, a little bit the detail of the governance model. But now at least we have a framework for governance. I told you about the IT governance, the governance model. So I thought whatever for that institutional research, computing capability has to be consistent with the governance and will be reviewed by the governance and by these governance, bodies, and also by external reviewers. So, but again, the one I want to point, without giving all the details, that there's going to be the structure that respects availability and priority and different access, tiered level that we can, we can come to agreement, so we can expand in a fair, transparent way, and essentially have a platform which is which is yours, which is really built by community, used by the community, and being expanded with the community. So with that, I'm going to have Tony say a few words about what this thing looks like, what are the capability, what are the in terms of the network, and also the platform. And after that, we'll wrap up with a timeline and some question periods.
Okay, clear. Can everyone hear me? I tend to talk loud anyway, so I'm not sure if I'll be hearing the speakers or I'll just be hearing myself. One of the things that, we could spend all day talking about the architecture, but really what we're talking about here is a culmination of almost a year and a half worth of effort. I still remember the first meeting when Dr. Kahn came into my office shortly after I'd been promoted to deputy and said, Tony, I have a problem that I need you to solve. And so we started with some basic discussions, and as we developed, when we first started the discussion to be able to meet Condo's needs, the initial solution wasn't the condominium at all. It was really talking about very targeted specific needs. But what we came to is this kind of a bit of an epiphany where we said, well, the problem is, as sizable as the amount of money that Connors had at the time, it wasn't sufficient to meet a broad representative needs that college had. In other words, it solved a lot of them, but there's just so many needs. So that's when, after I think it was 2 or 3 iterations of 4 proposals, we finally stepped back and said, you know what, we need to come together a larger group. And so that's where the conversation with this different money came in. But before I show you where we actually ended up, I do want to say something, in fact, about the way ITS is treating research computing, because as many as you are aware of at other institutions, there seems to be this constant debate or struggle about, is it better to have distributed research computing, or is it better to have consolidated, whatever that means for you. And to paraphrase one of my heroes, I think, is it too much for us to ask for both? So one of the things that was taken seriously by Diane and her team is I wanted them to swing for the fence. I wanted them to build an architecture, a model that scaled horizontally. I wanted it to scale vertically. I wanted it to be able to support very specific needs, but I also wanted it to be able to solve more generic. I wanted an architecture that could, over time, be as many things to as many people as it could be. And I think the solution they came up with that is a really good start down that path. So one thing to make very clear is, you see, if some of you look at this and say, well, that seems kind of small. This is just the beginning. This is just that initial investment. And where we believe we've got a story to tell you that is very collaborative in nature, and it scales not just to other places within Poland, particularly when I talk about the network, but it also scales to the other branch campuses. And so already right now there are conversations going on with our counterparts in Spokane and researchers up there how to scale to Spokane. We can do this. Okay? All right. So let's dive right into it. Okay? So at its heart, did I go the right way? Whoops, those are in the wrong order. Did I go the wrong way? Okay. So let's talk about it. I mean, at its heart, the technology side of this thing is a Dell-based blade compute system that also allows the ability, what we call, have large memory nodes, right? So you've got to be able to ask the clusters to be able to use MPI and other things to exert massive parallelism. We also have within this architecture the ability to have what we call large memory nodes, with a good start being around 2 terabytes of memory, that has a certain capacity to handle things where you don't necessarily need 100 or more cores, but you need just as much memory as you can get your hands on within a single environment. We also support GPU nodes, and we support both varieties, both the traditional AMD Tesla framework as well as the Intel-based PHY, just because it's an emergent thing. We want to have that capability. But the parts that don't get a lot of press or you pay attention to is kind of that dark matter, that iceberg underneath the waterline, and that's the actual component of the infrastructure. So things to pay attention to. So maybe the network backbone being 10 gig within the system isn't particularly earth-shattering, but for us to actually be able to create a foundation where we've got an InfiniBand backplane to be able to support that, that is, our approach to the cost-effective nature of that is what's impressive. And so for any type of research model or anything that you've got to perform, there's a way for you to use these basic building blocks, these basic Legos that they have designed, to then scale up, either vertically or sideways, to meet your need. The storage side has as many flexible options as well. Rather than just pick one, do we want to be fast and be SSD based, or do we want to be cost effective at the slower spindles so that we have large volumes? I said, let's do both. And by the way, it gives a little middle tier as well for the people who want the sweet spot in the middle. Okay? So as I walk through this, one of the basic premises of any condominium model is that if you can share the cost of infrastructure among various users, that's better than someone having to build it all. So we took that and took that to an extreme where we can scale linearly any one of these subsystems. So one of the things that I want to caution us is even though the approximate width of this can be 9 racks, that is to a certain extent an artificial constraint, really, because the first customer that comes in and buys some piece is going to want to build that condominium their way. And so we can scale each one of these out. Who knows, in a couple of years, maybe we will have only twice the amount of compute horsepower, but we'll have 10 times the storage. Maybe we'll have 5 times the compute, and it'll all be slower, but a lot more storage in the petabyte range. However you guys want to utilize this is what we are prepared to support. And I'll talk about the human element here in a minute. So probably the most, let's just say, controversial element of this slide was everybody was asking me about costs. And I resisted, but I deferred to a superior officer, both Christian and VP King, when they said, Tony, you got to give them something. So one of the things I want to stress here is what we have built, and by we I mean ITS, is a very fundamental cost model. And it's based upon costs that we either can outright measure, like the cost of specific technology, or the costs that we believe are going to be part of it. So this model has to be vetted, it has to be tested, and it has to be sold. You guys have to buy this. And so when we develop this, and to make sure that all things for all people, that's why we stress some of these costs may seem a little high, but it's always easier to define a very high level of support and availability and come down. When you guys say, Tony, I don't need that much meatware. No, I don't need that level of reliability. I don't need that performance. Great. But as scientists and researchers, you guys can understand, it's almost impossible to go the other way. If we had architected this for low cost and all that, and then somebody come and ask us to scale, unfortunately the technology doesn't work, or it doesn't do it linearly. And I wanted to avoid that. So let's start off by going down with that modeled end draft. This has not been vetted, so you are seeing this for the very first time. So let's take a look at that first one, that standard compute node, the bread and butter of a cluster. So when you take, that is not the right slide. Okay, I'm going to ad-lib this. Okay.
Hello. Slides, please. We cannot see the slides at outstations.
Okay. Are we not presenting content? Where's the? Okay, we'll get that. What location are you at?
Prosser.
Prosser? Okay. 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 So let me pull up my backup technology here, and let's take a look at that first number. And let's break that down a little bit. Okay. So if you take a look at that first thing, 2 Intel, 20 cores, 40 threads, 256 gig of RAM, and by the way, in that basic unit there, with that much horsepower, you don't want to put bicycle tires on a Ferrari. So that's why SSDs are really the only way to go with local storage on something like that. But it does have built into it 10 gigabit Ethernet, as well as an InfiniBand connector to plug into that grid. Now, when you take a look at that number, some of you may either roll your eyes or say, you know what, I can do that better, cheaper than myself. And you know what? If you can, please let us know how. All right. So when you break that cost down, now that is a 5-year cost based upon this model, but let me break it down for you. The blade itself Not including tax, by the way. And that was something that I just had to struggle with. We didn't pay tax on this system, so hopefully we can continue doing that. I'm not sure how we avoided sales tax, but we did so legally. The blade itself is only $7,600 acquisition cost at that number, right? Leaving almost $10,000. So where does that other $10,000 go? Well, $4,000 of it goes into the shared infrastructure. Those InfiniBand, for anybody who's ever priced one of those switches, it'll make your eyes glaze over. You can drop $40,000 into an InfiniBand switch pretty easily. Okay, so it's that. It's the network. It's the rack. It's the management node. It's the patch cables that hook it together. So for the part, it's the chassis that blade fits within. It's those technology components. Now, that leaves $5,600 in people costs. That is going to be the best way to manage these costs and look at that. Do we need to allocate that much human being? Out the gate, I think we do. If there was one thing that we have learned from the existing legacy HPC system, is that a lot of people could not utilize it because they could not get the support that they needed. And our model defines support in two different ways. On the system administration side, which is the care and the feeding and the performance tuning of the hardware, and then it's the actual software support, somebody who's more of an application specialist, somebody who's a software person, somebody who can bridge the gap between your language and the system administrators. And we have to find a very high level. We're trying to learn from other people's, I won't say mistakes, but people who kind of stepped into the software side. And as one institution we talked to, they said, you know what, you're doing this right. They started off with only one person, and particularly in that first couple of years as everybody was coming on board, that person represented a bottleneck to getting all of that work on board. That's why we want to start with two. Okay, so when you break that down, and I'll talk about the pricing details in a little bit. You can follow that same model on that large memory node, and that number is way off. Trust me, a 2 terabyte, the 2 terabytes of RAM alone cost $26,000. In that, it's actually a little bit more. Let's talk about the storage. I talked about the 3 tiers of it. And the costs there are not, I didn't give a range because we actually need to price each tier. Some of you may want an automatically balanced tiered storage where you want the average best performance. Some of you may specifically say, no, I need the fastest stuff you got and I want it all the time and I'm willing to pay for it. Some may want the more archived storage, the 7200. So as we price that out, we're going to have to develop that model to be as flexible as you would like. All right. So let's talk about the pricing details a little bit. It is based upon a 5-year life cycle, by the way, which is a little unusual. You see a lot of condominium models hitting the 3 or 4 year mark. To be able to get the most value out of that, our model is based on all of the equipment being in there for 5 years, and the underlying warranties and hardware contracts support that. Now, that doesn't mean, though, that you have to buy in for a full 5 years. The actual condominium models, most of them actually have you interact with at a 1 year.
Christian has the right slide.
Oh, does he? Oh, please. Okay. Yeah, okay, I'll keep talking. I can tell a joke or two if necessary. So the 5-year life cycle is just we've got to pick duration. There's nothing magical about that other than the fact that it's tied with most hardware manufacturers' warranties that they support. But so we believe that the ultimate pricing model will allow you to buy in at the more reasonable 1, 2, 3 year increments that you're thinking. What that does mean is that the royalty, you need to find out how to find another customer to sell it if you only want it for a year. That means we've got 5 other years that we've got to sell. Okay? So you will buy and pay for what you use and what you can rightfully call yours. Also, it'll be in the slide when we bring it up here. The support for the people, as I said before, we're making assumptions that we are going to hire and commit 2 system administrators to it. Now, there's a little caveat in there that is an opportunity to reduce cost, is that we only have secured institutional funding for the first 2 years of 1 position.
Tony,
Yes, sir. Ah, there we go. Now I feel much better. Okay, here's what I meant by the ranges. Okay, so the first one, the cost of the blade, that's $7,600, and that seems like a large spread, and it really has to do with fundamentally, this is what this point down here is. The given ranges are driven by SysAd, and infrastructure costs are ultimately covered. We have identified some commitments from the central organization, including ITS committing one full FTE to this initiative. But there's constraints. The FTE that we're giving is actually that position that's allocated to the existing legacy HPC. Fortunately, that system is getting close to end of life, and that has to be resolved one way or another. But that's where that comes into play. It includes costs for most IT-related infrastructure. The usual suspects are listed there. There are things that we need to do to be able to scale up something that's about power, and we're securing additional funding so that that doesn't have to be recovered as part of that. In other words, treating that more of a facilities or a data center cost as opposed to a condo cost. There's a bit of flexibility in the hardware configurations based upon the vendor's support. So I don't know if you guys think 256 gig of RAM is probably most people except the genomics think that, people. But but to put that in perspective, the size of that basic building block, that block is at least twice as fast as the current nodes that we have, which are no slouches, and it's 4 times the memory. So when you just talk about the latencies in your applications and the way the interprocess communication can happen within those, you're going to get a definite kick in the butt by joining this system. And they're only going to get faster. Yes, sir.
Sorry, Tony, could you just comment on like the compute know-how those costs, Georgia and Clemson? Compared to
yes.
Performance costs.
Good point. Well, let me deal with the easy one too. The thing that I'm proud of, because we are building this, right? We just bought this thing a few months ago. Is we are buying basically that sweet spot of new hardware. So compared to other people who have models, when you take a look at the horsepower that's in these nodes, they're about twice as fast as some of the other people's system, just because we're a couple of 3 years newer. So when you have to do a price performance in your head, and come up with your own definition of value. The reason we discuss ranges is that depending upon the underlying financial model at these institutions that you've either come from or you're comparing us against, or even within your own clusters that you may have now, you have to understand the underlying funding model and what level of subsidy or institutional commitment or college commitment that is covering what costs. So, on the high side, the $17,169.95 for that node is what we are predicting to be the fully loaded cost of that blade over a complete 5 years. Okay? Now, it doesn't include the cost of power because we, ITS, don't pay for our power, but that's one of the exceptions that's missing. That, in effect, is the cost with no subsidy whatsoever. Now, on the other end, at the $75,6149, that is what you as a researcher would pay it like at Clemson, where I believe the IT infrastructure is covered by other funding sources, not from the researchers, and possibly there. And I don't know enough about the Clemson's model to say this, but I also believe a fair amount of the system administration costs are also covered elsewhere. What we as an institution and what VP Keenan and Christian have to work with is to figure where are we along that continuum. And that's actually the hard.
And where does UW in that continuum?
UW is more on the higher side. They have an effective 25% subsidy rate, meaning their data center costs are covered, and there are a certain amount of infrastructure that's covered from a central resource. To put that in perspective, I believe the Clemsons and the ones that have a higher level of that are more in the they cover 50% of the cost, maybe as high if they cover all the infrastructure costs. Okay? So part of developing this model is we need to be very transparent on the costs and what they are so that we can have good discussions about it. But more importantly, I want to be very transparent because at the end of the day, you guys are going to tell me what costs should not be included, or is there a way to bring that number down, or whatever. And it's all going to be based around, as I said, if you just look at that first $17,000 number, a third of the cost are people. Pure and simple. Well, you want to say Q&A for later?
And I want you to talk about the network.
Yeah, I want to talk about the network. Okay, so as excited as I am about the cluster, the HPC Condo, it is really part of a bigger vision about making sure that we support and enhance research across the Pullman campus and at branch campuses as they wish. So actually, prior to actually getting the full commitment for this, we already, and by we, I'm going to give credit to, on the IT side, Tori, Byington, and Ms. Wallace here, I'm not sure who Wallace is, to apply for a grant that we were going to try to do a couple of years ago, but we really couldn't get our act together as an institution to submit a request. This time we were better prepared. So while our HPC Condo, and by the way, the Aeolus cluster, will be joining the HSSRC, this network is about everybody else in the buildings and that have compute resources that are not conveniently located in the data center. So what this is, and only lately did we find out that our approach to this is actually very unique. What we are doing isn't doing just the traditional overlay of dedicating high-speed networking equipment, traditional stuff that we use for the administrative. We're swinging, pardon me, we are swinging for the fence in that we are shooting at what your needs are going to be in 5 years. So the approach, without getting into the technology, but what this core does is actually builds, going down to the end, it builds a 320 gigabit ring around Pullman. Self-healing, bidirectional, point-to-point is supported. So what this really means to you as a researcher, if you came and said, Tony, I need a 10 gig drop fiber to my desk, or my lab, or my little data center, what we would do is focus on getting you to the and there's 5 drops on campus, conveniently located where our main communication facilities are. And we can provision, so the cost to you would be to make sure we just get into your building and to your lab to get that fiber. But you would be able to connect it effectively a non-blocking. You would have dedicated traffic, your own high-speed lane from that facility to any other facility that was tapped off that ring. All right. So because traditional hierarchies build on hierarchical, they scale and they have these aggregation points. That no matter how you build those, so those create inherent bottlenecks within your network. This ring doesn't do that. And by the way, at 321 gigabits, right now, state-of-the-art, local networks are only 100 gig. I presented this in front of an audience that had University of Washington representatives, and they came up afterwards asking me for the name of my networking engineer they could talk to find out how this stuff works. We are doing something the University of Washington had never even heard of before. This technology was developed out of MIT, by the way, and they've got a spin-off that's driving this. This is new. And so the vision of this is to actually build and extend to the other branch campuses that they like, is to build something that in effect builds as many point-to-point 10 gig tunnels where you guys need them to. And there's enough backhaul capacity at 320, you're not going to run into congestion with each other for a very long time. But by the way, that's just the start. This is built at 10 gigabit. But the core that we put in to give you non-blocking access to the internet, by the way, which is part of it, by the way, and I don't expect to get a round of applause here, but part of this architecture allows you as researchers to bypass my firewalls. We're getting out of your way. We offer those firewalls there are to deal with a few people who don't know how to patch their systems or click on URLs they don't. We trust that you know how to run your systems securely. And we're counting on that. Okay? You can do it. We'll help a little bit. You can do it. Okay, so as part of this, where we're swinging for it is actually 100 gig. I have already put our regional optical networks, the operators, their board of directors on notice. I'm telling you, you need to be ready to give us multiple diversion 100 gig paths into the national research fabric. And you better be ready when we come asking. We've already got our core ready. This other infrastructure can scale with it as well. So that comes down to the next point. That's fine. And as a matter of fact, the CEO of the Pacific Northwest Gigapop was kind of wagging his fingers at a lot of us. He goes, you guys are building science DMZs to nowhere. And I actually said, oh, with all due respect, sir, wait till I'm done with my presentation. Because we are planning on getting you into the national fabric. Some of you may only need to bounce your data around here. A lot of you will need to go to the branch campuses, and even more will need to go into the national fabric. So in that, we are actually rebuilding our relationship with the Gigapop, located in the Weston Building in Seattle, which is the network location. I don't know if all of you are aware, but we are quite fortunate to have UW operate that facility. It is one of the top Gigapops in the country. It's within the top 5, and it's in our backyard. That really plays to our advantage. So what we are doing is we're going to strengthen that without tying. We're not going to sacrifice any of our network relationships. We can't do that. We need to stay part of our regional community, but we can't let that hold us back. So what we have done last fall, and I got confirmation that we've actually signed the paper, so I can semi-announce it. But we will be taking and expanding two brand new 10 gig circuits from Pullman. Non-stop, high-speed expressway, no routers, no firewalls, all the way right into that 100 gig based facility in Seattle. We are then going to support your ability to hop onto similar high-speed connections through NLR or Internet 2 to be able to get you that traffic to wherever you need to, not just the Clemsons and a few of these others. We're going to facilitate that. I encourage you, light these bad boys up. Okay? Because the quicker we fill those, the quicker we can tell people we need that more capacity. 100 gig connectivity is going to become the new benchmark for institutional. To be competitive in your grants, you're going to be able to go, not just click the redundant 10 gig that you can do now. Tomorrow, we need 100 gig. We need those big, fast pipes going to the Weston Building, and then we also need to head south and east towards Colorado or Utah, where the next big hops are. But we're starting to lay that infrastructure so that when you guys come and we arrive there, hopefully a day or two before you actually need us to do it. And then last but not least, I mentioned we're taking care of the branch campuses. Well, we actually, I'm not being altruistic, we have needs for business continuity and disaster recovery as well. I don't know whether you heard about this little thing called a flood, where made us question how many eggs we want in that 10-10 basket. By the way, that was a freak of nature. We've got a report that says the probability of that happening again is basically near zero. But what we are doing is we're going to provision a new dedicated point-to-point connection between Pullman and Spokane with the vision of being able to give researchers to be able to interact with each other and basically not know that they're separated by 80 or 90 miles. That's our intent. So we're working very much hand in glove with the local IT staff, Sal Algiotti, previously mentioned up in Spokane, and his technical staff to make that happen. We're doing it for you. Okay?
Okay, thanks, Tony, for this detailed description of the enhanced infrastructure, both in terms of compute platform and also networking. So in terms of timeline, this is for the condominium aspect of the infrastructure. So we're sort of moving this forward, and so we're right on schedule. Today we talk about the acquisition delivery of the system in January. Today we sort of are rolling out this as an announcement. Over the term of the summer, the length of the summer, we'll be shaking down the machine, commissioning it, doing acceptance testing. The first order of business is really to get a subset of the community to discuss a governance model, which will be red teamed. So we'll have external reviewers looking at the governance model and ensure that it's consistent with the institution governance model, and starting access to the broader community in the fall, early fall, and then eventually, start the building up hardware again as consistent and as responsive to the need of the users that want to start buying in and providing hardware to this large infrastructure. Okay, so what comes next? So we talked a lot about the wires, the wavelength, and the compute, the memory. So now that this thing is being set up, and as we're building the infrastructure, we're hiring the people, we have to flesh out a transparent governance model. So that's going to be our next stop, doing the Condo Computing Governance Board, setting that up. Again, as I mentioned, there's already a research computing subcommittee. We're going to drop on that, but basically tailor it to the governance. And again, respecting the priority and the access of the investors and the sponsors. And then make sure it's consistent, again, with the governance model of the university. And also, again, look at other universities to adopt best practices for existing similar infrastructure, and having this theme external review. Okay, so we have time for a few questions, but in very short order, there will be further information, including this particular presentation on the Office of Research site, and there will be online forms available for you to provide, comments, feedback, so we can continuously improve the process, the infrastructure, so we can be responsive to the needs of the community. And with that, I would like to, again, thank you for your interest and your participation, and we'll welcome your feedback and input. So we have, again, there's going to be, the information is going to be available online as we build the system. A description of the system will also be available. We'll be linking with some of the pages from ITS, and make sure there's one place shopping where you can actually, one-stop shop where you can find all this information, at least that they're clearly linked together. And with that, I would like to thank you, and Tony and I would like to take a few questions from the AMS side or from the audience here at Condo. What I will do, if you have questions, I can just repeat the question, maybe it's easier. So, yes.
Maybe I just missed the point that you mentioned. The price, the cost of the one standard rack is between $8,000 to $18,000.
Mm-hmm.
What would you expect the faculty or researcher to pay for? On the lower end or on the higher end?
Oh boy, where's BB King when you need him? The question is dependent upon the level of underlying subsidy, and right now there are a lot of discussions about how to come in. Okay, so do I expect it to be on the high side? No. I mean, even when we look at when we can realize, let me just talk about our commitment in FTE. That represents easily $3,000 of that over that 5-year period. That's $3,000 right there. As soon as we can address our existing legacy HPC, we can put that resource on the table. There's no reason to pay for that. And that over the 5-year period, let's see if I can remember my number. That's pushing multi-$100,000 contribution. And so, it really is going to come down to what you guys want in terms of that support for that. And to be clear, we're talking about FTE. We're giving them labels, and I think what we need to define is exactly what you need from them, so that we give you the opportunity to give you the opportunity to get your needs met. I don't know. Can we be somewhere in the middle?
Thank you. Yeah.
You're welcome.
I have a quick question from Vancouver.
Go ahead.
Yeah, could you guys remind us what was the time scale for improving the network speed for the branch campuses?
At this point, the Pullman HSRC, we're hoping to have that up midsummer. We're still working on defining the requirements for the connectivity to Spokane and Seattle. We are actively engaging in your case. I don't know if Michael Stamper is there, your new campus CIO, but we're talking to him about how, what that type of a strategy should be, and we should be doing the same thing for Tri-City. So there is no time frame for those two locations, and we're just starting those conversations.
Thank you.
Okay.
Question?
So, two questions. So if you contribute to the your own condo, I assume that you'll have some sort of restrictions on what are acceptable as a unit, right? And then what is what kind of thing do you own that? But
Yes.
then you must get something back for that contribution, right? Because you're letting other people use that unit.
Correct.
But
So you get something back in return for letting other people use that?
the question is about preemption. So essentially, from your perspective, it's like you own it all the time. So the people that use your hardware, once you want to have access, they're being disabled.
Yeah, oh, so you're using it free of charge? I mean,
Well, you contributed to it.
right, but you're still paying the price, underlying price for use of the condo, but you're contributing your own condo? I guess I don't quite understand how that works.
No, okay, so when you buy into the condo, and that's why we as a university have to really understand what that level of subsidy is. To make any condominium work, to make it reasonable to you when you're not using it. In other words, if you got the job, you can light that thing up 24 by 365. It's those unused cycles when you're not using it at your discretion that are harvested. And then the value of exchange is that level of subsidy, the costs that you are not paying. Right? If there was no subsidy whatsoever, your point would be valid. Somebody's using my equipment and I'm not receiving anything back.
Right.
But as you work out the model, what you're getting is, in other words, you're saying, okay, I'm receiving, let's just throw out a number, a 25% subsidy. There's 25% of the cost to support me that I'm not paying. In exchange, I'm willing to let other people use my cycles.
Right, got it.
That's
what the subsidy is that you're talking
Right. But you also, as an owner, as a user, as an investor, you have access to what you purchase, but you also have access to other people's.
Got it.
All right.
The bursting ability. Yeah, we didn't really talk about
Okay,
that.
I mean, I
I
think-
understand. Okay, I got
Right.
it now. So that's the whole idea of that.
Yes.
Contributing. Okay, got it. And my second question was, I mean, I love this whole thing about the ring and all that, but in a great point of irony, having all the computer science and electrical engineers in the EME building. My understanding from one of your people is that we don't actually have access to the 10 gigabit because you can't get into our building because we have asbestos.
Okay. So let me see if I can give you a.
Do you want to repeat the question?
Okay, what was the question? Okay, so can I rephrase the question?
Yes.
Your concern is that 70% of WSU, not just the engineering, 70% of this campus is Pullman is still wired with Cat3, which at best limits you to 10 megabit full duplex connection.
Yeah.
In engineering, my staff have actually worked with your researcher and your faculty, and some of you aren't even getting that. Some of you are not even technically running Ethernet because you're only getting like 10 megabit half duplex. I mean, it's telephone cable for all intents and purposes.
Yes.
So specifically to be able to partner with you, and it was engineering PIs whose name are on the
I know,
grant. It's
I
not
know.
mine.
I know.
I'm not qualified. But so what we have done as part of that project is you actually already have a 10 gig drop in the building, but we're kind of doing a little re-architecture to make that be more friendly to researchers is the best way to put it. And so the at least that main drop, and then we are specifically connecting to engineering's Aeolus cluster, which is the second largest cluster at WSU.
Right.
So then what that leaves is very much what I would call that last 100-meter problem, which is upgrading the individual researcher's connection to Cat 5 or 6. And that is where, yes, the cost of upgrading that because of the asbestos and poor pathways is a $2,000 to $3,000 expenditure per drop.
Right. Got it.
That was longer than 60 seconds, but I think I actually, and by the way, that is, and I have to be careful because I'm not speaking for ITS, on my personal top 5 list, this Cat 3 is the third largest IT problem at WSU. And the sooner we get started on it, the sooner we get a new CIO who can help us find those resources, we can. But I don't want to take any more, but we have a wonderful story to tell you about our vision for doing fiber to the desktop. Our vision is, forget this copper stuff. Copper's so 1990s.
Right.
Let's go with single mode fiber whose bandwidth is unlimited. It's up to the physicists and the engineers to get us the bandwidth out of that. That's your job.
Right. Thank you.
You're welcome.
Dave, did you have a question? Or then we'll take one here, then we'll take one from the field.
So for the CPU, why do you choose the version 2, not the newest version, which is the version 3?
You know, its price point, I'll defer to the technical. I think we have the capability, when they reach GA, I think we're planning on putting on the price sheet.
Yeah, this was spec'd in November, and actually, so those specific processors are right at the inflection point of cost for cost by performance. So they're right on the inflection point of this is the maximum amount of computational ability that you can get out per dollar. So that's the reason why those are spec'd there. And yeah, as soon as the next generation of this hardware platform comes out, which should be here in the next year, we'll respec it again and put in probably the Gen 3s.
Are the Gen 3s even available from Dell right now for these chassis? Yeah. See, that's the other thing. Sometimes the way the manufacturers work, even though they announce it and have it available, particularly conservative companies like Dell take a little while before they start shoving these in at the density they can. So there's a little bit of a lag time. Trust me, part of the philosophy here is density and just cramming the fastest things and as long as we can handle the heat, we want to do that.
Any questions from the field? From the campus? I guess not. We any question from the right.
Can you talk a little bit about what kind of software inventory you are considering? Say, MATLAB, Canvas, license, SaaS, or something like that?
I can chime in. The question was about site license for widely used software. We're looking at that. What we're trying to do with that study, that inventory, is actually come to gather data to document the fact that people are spending as much for individual license that it would cost to have a site license. So that's the first step towards doing that. So there's low-hanging fruit in which there's lots of users already paying for licenses, but their platform looking into getting a site license because the costs are already being spent.
So another way to answer the question is that Christian is surveying people in engineering, physical sciences, math, things like that. I'm surveying people who are doing biological applications. You should send us an email. You'll get back a table to fill in so that we can get all the data and put it together in a uniform way. But we're trying to get some idea of what people want to be on the system. And then if people are using software that costs money, trying to get some idea of how we might be able to integrate that. For instance, MATLAB on this computer might be run under a different model than the current individual license model that I'm not sure I can call it a model. The individual license arrangement that we currently have here, we might negotiate something with MATLAB that will provide certain applications at least on this system. Does that answer your question?
Right. So we're trying to cast as broad a net as we can, and I think that this side will have this information where you can submit your request with the formula. And see, we kind of divided, between the life science and the physical sciences, but we want to catch all the colleges. This is where we're going to start, and this is exactly why we're doing it. Any other questions? I guess. Okay. If not, well, thanks again for your participation, and we look forward to working with you.
Thank you for your time.
Thank you for your time.